Hello everyone, I'm Miss K and welcome back to MOREducation. Today we're going to be looking at the development of the periodic table. Our learning objectives: know how the elements were previously arranged by Newland and Mendeleev, describe the steps in the development of the periodic table, and explain the similarities and differences between the previous periodic tables and the modern periodic table. Okay, let's get started. In 1864, John Newland arranged the early elements by their atomic mass, and he noticed a pattern which he called the law of octaves. Every eighth element had similar properties. So let's have a look at his table. We have beryllium, and if you count 8 elements along, you will get to magnesium, which has similar properties. However, Newland's table had the following challenges. There is more than one element in some boxes. He did not consider that scientists would discover new elements. Metals and non-metals are in the same group. For example, we've got nickel and bromine. Due to all of these discoveries about the element groups in Newland's periodic table, another scientist solved the problem in 1869. And this scientist was called Dmitri Mendeleev. He arranged the early elements by their atomic mass. Elements were also arranged in groups of similar properties. He left gaps for undiscovered elements and predicted the properties of these elements. So here is Mendeleev's table. As you can see, he has left gaps which allowed room for when new elements were discovered. A few years later, new elements were discovered and they matched Mendeleev's predictions. However, not all of the new elements fit into Mendeleev's pattern due to their atomic weights. He changed their order where necessary to keep the elements with similar properties in the same group. In the early 20th century, scientists researched more into the structure of an atom and isotopes. Isotopes accounted for the odd atomic weights of some elements. And here we have the modern periodic table. The groups go vertically, the periods are going horizontal. The elements are grouped by the number of electrons in their outer shell. So for example, magnesium is in group 2 and it has 2 electrons on its outer shell. The elements are arranged by atomic number and there are no gaps. So all the elements up to a certain atomic number have been discovered. The metals have been arranged on the left-hand side and the non-metals are on the right-hand side. And we will look more into groups, chemical properties and reactivity in the following videos to come. So progress check. Question 1. Compare Newland's and Mendeleev's tables and give one reason why scientists accepted Mendeleev's table. That's worth 4 marks. Then question 2, suggest 2 reasons why other scientists did not accept Mendeleev's periodic table, and that's worth 2 marks. Pause the video, give yourself 6 minutes to answer the question, and then when you're ready, press play. Question 1, only 3 from the following for the comparisons. Both tables have more than one element in a box. Both have similar elements in the same column. Both are missing the noble gases, so the noble gases had not been discovered by that time. Both arranged elements in order of their atomic weights. And then one of the following for the final mark. Mendeleev predicted properties of missing elements. Elements with properties predicted by Mendeleev were discovered. Mendeleev's predictions turned out to be correct. Elements were discovered which fitted the gaps. Question 2, so any 2 from the following, they were put in order of mass. He left gaps, or you could have said the table was not complete. There was no evidence for undiscovered elements. He changed the order of some elements, or there were exceptions to the rule. And then finally, he put metals and non-metals together. Thanks for watching. I hope you've learned a lot about the history of the periodic table. Don't forget to subscribe. I'm Miss K and this is More Education.